but I can. I think though, so I just pressed record. I think, you know, most of the things we had talked about yesterday.
Okay.
So I think that video should answer kind of all of the same questions.
Mm-hmm.
I think maybe the only thing that we did today that was a little different was going over kind of what you had asked, which is, you know, what is new that we didn't cover in class. And so that was just, we had started talking about conceptually what is the t-test, but actually calculating it. And we did talk yesterday about, you know, how you're just calculating the numerator, taking the difference between the means, and then using that denominator that I give you, rather than having to use this big complicated formula. And we talked about the null and the research hypothesis in that one. We talked about degrees of freedom, so taking your two sample sizes, adding them together, subtracting 2, and then using that to get your t critical value from the table. So, and I think, you know, one of the questions was, as you had mentioned, how much bigger does the t that you obtain or calculate have to be compared to the critical value? And like we said, it's just kind of an all or nothing. As long as the one that you calculated is larger than the one that you get from the table, then you reject the null and say that there are significant differences between the groups. If the one that you calculate, is smaller than the one from the table, then you retain the null or support the null.
And what if it's the same number?
If it's exactly the same, then you should, it's exactly the same.
Would that like never happen?
I mean, it could, theoretically. Let me look real quick at the table again. Okay. Level of significance, corresponding to various levels of probability. Well, for us, if it's exactly the same, I would say reject the null hypothesis. Particularly because based on this table, you're using degrees of freedom that are actually a little bit smaller than what we actually had.
Okay.
So if it was exactly the same, I would go ahead and reject the null. Okay. Typically what happens when we actually do analyses, and we'll kind of see this with our project, is that there are programs to calculate the exact probability level or the exact p-value. So here we're using these tables to estimate it. So that's where it's a little tricky. But when you're actually calculating the exact p-value, then it's a little more straightforward of what you do. Okay. In that situation, yeah.
And where do we go to access the recording from yesterday? And if we need to go back and look at the one from today?
Oh, yes, so I put the one, and let me make sure after I messed up the last thing that I posted. Okay. So unit 2, yes, okay. Video tutorials, so underneath appendix tables, you have video tutorials. You have a lot of different things. At the very end is a video that's answers to Zoom questions. And then I'll post this one under that one.
Okay, all right.
Yeah. And so, as I told my other people, in order to get them onto Canvas, given the file sizes, I have to link them through YouTube. but no one watches my channel. So if you're worried about like people hearing you, no one watches. So it's pretty much just us.
So I actually had a question, so when like for a question, we don't have to use the exact same one from the exam, but I guess I'm a bit confused as how we're supposed to find the percentage of scores when they're asking it to be between two numbers. Is that something that we're still looking at the table for?
Yes. Okay. So let's see. We have fall between 38 and 52. Let me see. Okay. So for this one, I made it kind of easy. So if you notice, our population mean is, let me switch over. Okay. So here we have our measure of anxiety. Our population mean is 45. Our standard deviation is 7. And so this is kind of you could do the same thing if you had like a harder version of this, but this one I made kind of more simple because if you notice, this is 1 standard deviation below and 1 standard deviation above, right? So if the mean is 45 and the standard deviation is 7, if you subtract 7 from 45, you get 38. And if you add 7 to 45, you get 52. So we're talking about 1 standard deviation above, 1 standard deviation below. So you could use your Z table and you could look up, okay, well, what's 1 standard deviation, 34.13, but really you can go to, let's see if we had it in the slides somewhere. I think we kind of talked about this a little bit in the slides. That would have been in chapter 5. Do I have a picture of the normal curves there? Yep, there we go. Okay. So you don't even have to really use the Z table for this one. You can just look at this picture of the normal curve, right? And so basically what it's saying is, what is this area between 1 standard deviation below and 1 standard deviation above? And so it's just 34.13 plus 34.13. Which should be, right, about 68%, right? So that's all it's asking. It's just asking that area.
Oh, okay. I see.
But even if you use the table on that one, you should get this. You should get the same thing because you would be looking at. Where's my Z table? You'd be looking at the Z-score of 1, and you've got area between the mean and 1, and you would know that that's this. Well, you also need the other side too, so you just double it.
Okay. And it's always 1.0 that you're looking at?
For that one, based on what the mean and the standard deviation were. Right?
Okay.
Yeah.
Well,
yeah, so the next one below it, it'll be different, right? Because your Z-score will be different for that one.
Right.
All right. Any other questions, thoughts?
No, I think that's it for me. Thank you very much for making this Zoom because I didn't even realize how lost I was. So
Okay, good. Yeah, I mean, most people, it was kind of hard to tell from the homework actually. And so it seemed like most people were kind of on the right track, just that like they were missing kind of little tricky things.